Welcome students. We have already started with yield line analysis. So today in this video lecture we will be learning different methods of analysis. Correct yield line pattern is one which gives the lowest ultimate load and highest ultimate moment. Yield line theory is based on the upper bound approach. Now, what is this upper bound approach? It states that the ultimate load computed on the basis of an assumed yield line pattern is either greater than or at the best equal to the true collapse load. So, there are basically two methods of analysis. One is virtual work method and second one is equilibrium method. We will be learning virtual work method in detail. Equilibrium method, if we get time, then we will go ahead with it. Okay, so for now we will be only learning virtual work method to solve the numericals. So to start, it states that if a rigid body is in static equilibrium under the action of set of forces is given a virtual displacement, the sum of virtual work done by external forces and by internal forces is equal to 0. Okay, so basically if any body is in equilibrium, static equilibrium, and if you give any displacement or if you apply some force from external force or any force, then the sum of the work done by internal forces and external forces is equal. When you say the sum is equal to 0, that means the work done by internal forces and work done by external forces are same. Okay, so slab gets divided into number of segments when it comes to yield line pattern. So here if you see in the diagram, if you see the square slab and the yield line pattern, it forms or it divides the slab into 4 segments. So this is the first segment, this is the second one, this is third, and this is fourth. These are individual segments and these segments are triangular segments. So a square slab is divided into triangular segments by the yield line pattern. Similarly, if you see the rectangular slab here, the yield line pattern is we have already covered these yield line patterns in the previous lecture. We have already covered this in the previous lecture. So again, this particular yield line pattern divides the slab into 4 segments, 2 triangular segments and 3 and 4 as trapezoidal segments. Okay, so each segment of slab can be considered as a rigid body. So now each segment can be considered for analysis purpose. So we can consider this trapezoidal as one segment, we can consider this triangle as another segment, and also each segment is in equilibrium. So these assumptions you will understand when we will start doing the numericals. Okay, so basically you should know what are these segments and how they are considered. Now slab analysis. As the slab is in static equilibrium under the system of forces, a small displacement delta is given at some convenient point in the direction of the load. So now we have to consider or we have to see what is this external forces or virtual work done by external forces and what is this virtual work done by internal forces. Now if you want to calculate this external work and internal work, we need to give a displacement, okay, to the slab which is in static equilibrium. So that displacement is considered as a value delta here. Okay, a small value delta is given at some convenient point. Of course, it has to be in the direction of the load. Then only it will get displaced. If it is opposite, then it becomes a reaction. Okay, so then the resulting displacement at all points of the slab can be expressed in terms of the resulting displacement at all points of the slab can be expressed in terms of delta only, that is the displacement given. The external work done by a uniformly distributed ultimate load of intensity Wu is given by external work, we can write it as the total load into the displacement. So displacement will be in both the direction dx and dy. So delta is displacement, so we write it as Wu into delta dx dy. Okay, so it will be very, very small, so we are writing it as dx dy. So this same dx dy can be written as delta g. So delta g is basically vertical displacement at its CG, that is center of gravity of the slab, and Wu is total load on the segment. Now this load is always a uniformly distributed load, as the load considered on the slabs is always uniformly distributed load. Now equation 1, that is the previous equation, can be written as WU into delta G, which is equal to WU into volume that is displaced. When I say delta X into delta Y, we can consider the total volume that is displaced. So external work is equal to summation of WU into area into delta times G. Okay, it is delta G, where W is intensity of ultimate load per unit area, AS is area of each segment of yield line pattern, and delta G is vertical displacement of CG of segment. This is very simple. This you have already, actually virtual work method we have already learnt in many of the concepts. We use this virtual work method to derive many other things. So it is not only that it is one of the method used for yield line analysis, but it is a general methodology that is used to calculate the internal work done and external work done. Okay. So now going to internal work done. External work done is the load that is acting on the structure. So we consider W. It is the external load that is experienced by the slab. Now due to this load, there are some changes that happens in the segment, or that is a reaction that happens in the segment. We call it as side effect. Okay. So because of the load, that is WU, there is a side effect of movement of resistance, that is MUN. So because of this load, there is some movement that is generated. Because of this movement, there is some change in length, there will be some rotation, and we need to consider all these factors to go ahead. So let MUN be the moment of resistance per unit length of yield line of length Ln. So it is just considered as Ln and undergoing relative rotation of theta n. So when there is a moment, that length has to be considered, for which that moment of resistance is acting. And because of the moment, there will be rotations at the support. So we need to consider rotation, that is theta n. About the yield line, that is along the direction of bending. Then the internal work done can be written as minus. Now why minus? Because it is going to undergo change, displacement. So we consider it as an opposite direction of what is external load. So it has to be negative. Summation of MUN into Ln into theta n. Why it is multiplied? The total movement is acting on the total length, and this will undergo total rotation, that is theta n. Then the virtual work equation can be written as external work done plus internal work done equal to 0. This is the statement of virtual work method. That is external work done, summation of external work plus internal work is equal to 0. So just substituting that equation 1, that is external work done and internal work done, we get this equation. So it is summation of W AS into delta G minus MUN, or summation of MUN Ln into theta n equal to 0. So basically here we prove that external work done is equal to internal work done. Okay, so this is the final equation to solve or to get yield line analysis by virtual work method. This is very standard equation which is used to solve numericals and to derive equations for different standard cases. So you have to only remember external work done and internal work done. So any case that is given to you, you should be able to write it down in these terms. That is the external load, area of the segment, displacement of the segment, that is delta G, MUN, that is the total movement experienced by the segment, Ln is the length of the segment, and theta n is the rotation of the segment. Okay, so this equation, from exam point of view, you do not have this equation, but you need to know how you have got this. Now based on this equation, we will be deriving many more equations or many more values for movement or values of WU for different standard cases like square simply supported slab, square fixed slab, rectangular simply supported slab, rectangular fixed slab, circular slab, and so on. So we will be doing these derivations in coming classes. Thank you.